So we're going to find the radius of convergence of this power series that currently is written in expanded form. And so our first goal is going to be to write it in its closed form with using our summation notation. So we want to identify patterns. Well, we could always have n start at 1, in which case we see a very clear pattern in the numerator. It's just n x to the n. And this again, if we have n start at 1, we could do 0 and put in n plus 1 there, and that's fine as well. Actually, putting in 0 would make the first term 0, so that'd actually still be the exact same. The denominator, notice what's happening. It's going up by 2 each time, right? Well, our function that increases by 2 each time is a linear function, so we know we have a slope of 2, so that's our slope there. So the denominator is going to have the form 2n. Now it needs to be odd, so we either need to add 1 or subtract 1. Well, we want this first term to start at 3, so we're going to want it to be plus 1, because when we plug 1 in, we're going to have 2 times 1 plus 1, and there's our 3. This is going to go to infinity. So there's our summation notation. Now we're ready to apply our ratio test and see what our radius of convergence is. So first thing we do is we find a sub n plus 1. So basically add 1 to all our n's. Don't forget your parentheses there. That's a very common mistake. And 2n plus 1, and then we just multiply by the reciprocal of a sub n, or the original. Alright, we're going to do a little bit of rewriting and see what kind of canceling we can do. We'll leave this as n plus 1. This will rewrite as x to the n times x. We'll just put it all in the same numerator. 2n plus 1 we'll leave alone. This I'm going to multiply through and add the 1. So 2n. Then this will be a plus 2, but then plus another 1. So plus 3 is actually that term there. And x to the n. Now, as is common in these, the x to the n's will cancel out. And now this no longer depends on n, so I like pulling it out of the limit. You don't have to do that, but I think it makes it easier for me to focus on the limit. Now, in the numerator, I got, n plus 1 times 2n plus 1. And in the denominator, I have 2n plus 3 times n. Now we have a couple options here. We have an infinity over infinity case. You might want to use L'Hopital's, or you can multiply things out. Let's say we decide to multiply things out. We'll have 2n squared plus 3n plus 1 over 2n squared plus 3n. Now if we didn't know what this was, you might already, and that's fine. But let's say we didn't. We would use L'Hopital's rule, which means we do the derivative of the top over the derivative of the bottom and recalculate our limit. Well, the derivative of the top is 4n plus 3, and the derivative of the bottom is also 4n plus 3, which is 1, so the limit as n goes to infinity is 1. So this is just the absolute value of x. We want it to be less than 1 in order for the ratio test to converge, and hence the 1 is our radius of convergence. A lot of times we'll just call it a capital R.